Yep. Right. May it please the court, your honors, I, Joaquin Cruz, and my partner Jacob Shaw represent the petitioner, the people in this case. Today, the question in front of this court is very simple. Is oil a finite resource? I'll speak on the first point of error, how is oil created, which is a fundamental aspect to this entire case. We'll prove what oil actually is, how it is created, and what is happening in the oil markets today. To do so, we pose a question. Why does everybody seem to believe in Hubert's peak oil theory? Why does the public believe in this theory? Within our argument, I present convincing evidence that peak oil is a theory based on a false premise that oil is a finite resource, and I'll show how oil is actually created. Sir Fred Hoyle in 1982 commented the suggestion that petroleum might have arisen from some transformation of squash fish or biological detritus is surely the silliest notion to have been entertained by a substantial number of people for an extended period of time. Charles E. Melton and A. Gardini in 1983 explained, the general concept of petroleum formation by biogenic mechanisms has been firmly entrenched for a long time, but there has been no accumulation of convincing experimental evidence in support of this belief. Currently, the publicly held theory is that crude oil and gas are both derived through the natural and lengthy decomposition of organic detritus. Therefore, people would naturally believe oil is a finite resource and that will eventually run out. In this courtroom today, we will show you that oil and gas are continuously formed or replaced from a purely physical and chemical thermodynamic process that continuously regenerates oil from ultra-deep locations below 9,000 meters. And the inference here is that oil may perhaps not be a finite resource and that there is plenty of it. First, oil and gas origins, biogenic or abiotic. Do oil and gas originate from biological decomposition of organic material, or do they originate simply through a natural physical and chemical thermodynamic process, abiotic? It is notable that the whole of Hubert's theory of peak oil rests completely on the assumption that oil is a finite resource. Therefore, oil that is biogenic in origin. Therefore, it is an oil. Therefore, oil is a finite resource. Simply, everyone believes this because everyone believes that this is a proven fact. I've also read that this biogenic theory directly contradicts and offends the second law of thermodynamics. Evidence for the Western biogenic theory of oil formation. First, in 1757, Russian scholar and scientist Mikhail Lomonosov put forward a hypothesis and suggested that oil may come from biological detritus. This was based upon the theory that was first introduced by George Agricole in 1556. George based his work on the Greek Aristotle's work in 1757, applying little more than observation and limited analytical tools available in his time. Russian scholar Lomonosov is generally considered to have followed the theory that crude oil, after pre-corroding for a great duration of time, might originate from biological material. The notion that oil is a fossil fuel was first proposed by Russian scholar Lomonosov in 1757. Lomonosov's rudimentary hypothesis, based on the limited base of scientific knowledge that existed at that time, and his own simple observations, was that rock oil originates as tiny bodies of animals buried in the sediments, which, under the influence of increased temperature and pressure acting during an unimaginably long period of time, transform into rock oil. 2.5 centuries later, Lomonosov's theory remains as it was in 1757, an unproved and almost entirely speculative hypothesis. Returning once again to the Wall Street Journal, we find that although the world has been drilling for oil for generations, little is known about the nature of the resource or the underground activities that led to its creation. In spite of this great amount of scientific research, there remain many unresolved questions regarding its origins. Does that not seem a little odd? We are talking here, after all, about a resource that by all accounts plays a crucial role in a vast array of human endeavors. By one published account, petroleum is a raw ingredient in some 70,000 manufactured products. By many accounts, the very survival of the human race is entirely dependent on the availability of petroleum. And yet we know almost nothing about this most life-sustaining Earth's resources. And even though by some shrill accounts the well is about to run dry, no one seems to be overly concerned with continuing to embrace understanding the nature of the origin of so-called fossil fuels. We are rather content with continuing to embrace an unproved 18th century theory that is subjected to any sort of logical analysis seems ludicrous. As anyone who stayed awake during high school science class knows, oil comes from dinosaurs. I remember as a student hearing my teacher go over and over the fact that oil was a fossil fuel, and we were running out of it. It seemed a reasonable enough idea at the time from the perspective of a 16-year-old, but if as an adult you really stop to give it some thought, doesn't the idea seem preposterous? How could dinosaurs have possibly created the planet's vast oil fields? Did millions or even billions of them die at the very same time and at the very same place? Were there Jonestowns on a grand scale occurring at locations all across the planet? And how did they all get buried so quickly? Because if they weren't buried right away, wouldn't they have just decomposed or been consumed by scavengers? And how much oil can you really squeeze from Apollo's parched dinosaur skeletons? How many dead dinosaurs does it take to make a barrel of oil? How many barrels of oil have we used so far? If dinosaurs caused the oil, or more correctly, their decomposing bodies caused the oil, then shouldn't it be a simple formula to figure out how many dinosaurs it took to make the oil? Isn't this science in reverse? If oil were a fossil fuel, could you not figure out this one simple fact? Also, wouldn't that make all oil the same age? But if all oil were the same age, that would mean that the dinosaurs that made the oil all died at the same time. Correct. Maybe there was some type of cataclysmic event that caused the sudden extinction of dinosaurs and also buried them, like the impact of an asteroid or comet. But even so, you wouldn't think that all dinosaurs would have been huddled together waiting to become oil fields. And besides, scientists are now backing away from this mass extinction theory. Does this mean that without a mass extinction, we could not have oil as a fossil fuel? Does it also mean that since all we have today in one oil field was all made at one time, that all oil had to come from some sort of sudden extinction? Then if dinosaurs lived for millions of years before, what did their dead bodies produce? Therefore, it would take a pretty big pile of dead dinosaurs to produce the oil. I don't know the precise dinosaur carcass to barrel of oil conversion rate is, but it does seem like it would take a hell of a lot of dead dinosaurs. Even if we generously allow that a single dinosaur could yield 5 barrels of oil, an absurd notion, but let's play along for now. More than 130 billion dinosaurs would have to be simultaneously entombed in just one small region of the world. But were there really hundreds of billions of dinosaurs roaming the earth? If so, then one wonders why there is all this talk now of overpopulation and scarce resources when all we are currently dealing with is a few billion humans populating the same earth. Could the earth have had 130 billion dinosaurs in one place like the Middle East? Now you would also have to multiply that for the United States, Mexico, Venezuela, Russia, Nigeria, and all other leading oil producing areas of the world. Quickly, you would see that we would have over 1 trillion dinosaurs on Earth, all dying at one time. We have found some fossils, but have we found them in that type of scale? The answer is a resounding no. And why the Middle East? Was that region some kind of mecca for dinosaurs? Was it the climate or the lack of water and vegetation that drew them there? Of course, the region could have been much different in prehistoric times. Maybe it was like the Great Valley and the land before time's Middle East. Or maybe the dinosaurs had to cross the Middle East to get to the Great Valley, but they never made it because they got bogged down in the desert and ultimately became, through I'm guessing here, some alchemic process, cans of mortar oil. Another version of the fossil fuel story holds that microscopic animal carcasses and other biological matter gathered on the world's seafloors, with that organic matter then being covered over with sediment over the course of millions of years, would turn into oil. You would think, however, that any biological matter would decompose long before being covered over by sediment, but I guess not. And I guess there were no bottom feeders in those days to clear the ocean floors of organic debris. Fair enough, but I still don't understand how those massive piles of biological debris, some consisting of hundreds of billions of tons of matter, could have just suddenly appeared so that they could then sit undisturbed for millions of years as they were covered over with sediment. I couldn't understand how biological detritus could accumulate over time mixed in with sediment, but that wouldn't really create the conditions for the generation of vast reservoirs of crude oil. So I guess I must be missing something here. This theory makes some sense, correct? How come we found that most cases that places have produced oil in the past, West Texas and the Middle East, for example, were old seabeds, so maybe this theory is correct. It wasn't the dinosaurs entirely, it was all of the other plants and animals in the ocean that died. This makes perfect sense until you begin to apply some questions like, did all the plants and animals in the ocean die at once? How can you have oil created from the surface of the earth downward and have the oil at the top the same age as the oil at the bottom? Simply you can't, because according to their own theory, the oil had to be made out at all once. For example, let's look at a cook preparing a kettle of homemade soup. He puts the stock in the kettle, heats the kettle, and slowly adds different parts of the soup. As the soup is cooking, he continues to add ingredients. He adds ingredients until the exact time the soup is served. Would all ingredients be cooked? Would all ingredients be done? The answer is, of course not. I realize that it is soup and not oil, but the analogy is very much the same. You must question the fact that biologically speaking, for oil to be biotic, it would have a single source or cause and would have to be cooked from the bottom up, not the top down. This means clearly that if oil is a fossil fuel, fossils have to be found at the base of the deposits of oil. That means fossils would be found at levels deeper than the oil is currently being pumped at. Today, Russia has many oil wells that are over 30,000 feet deep, yet the deepest a fossil has been found is at 16,000 feet below the surface of the Earth. In conclusion, let's compare the two theories of how oil was created and see which one makes more sense. In Lamontville's theory of 1757, you either had trillions of dinosaurs dying at the same time, or plants and animals in the ocean dying. After they die, they all decay at the same time and create oil. Cross-apply these factors. First, for oil to be a fossil fuel, we would have to be overpopulated with dinosaurs. Second, they all had to die at the same time. Third, oil on the top of the oil field would have to be newer than the oil at the bottom of the field. Fourth, fossils would have to be found at the bottom of all areas that have been drilled. The interesting fact is that none of this happened. Bones of dinosaurs have not been found in numbers sufficient to justify point one. No scientific evidence has been shown to cause point number two. The age of oil in the oil field doesn't differ, and fossils have been found only to 16,000 feet deep, even though they're producing wells twice as deep. Whereas the abiotic petroleum hypothesis first gained significant exposure outside the Soviet Union during the 1977 gasoline crisis, when Cornell astrophysicist Thomas Gold published an editorial in the Wall Street Journal in which he claimed that most deep hydrocarbons are generated abiotically in the mantle and migrate to the crust, where they act as an energy source for microbes producing deep microbial ecosystem, the deep hot biosphere, that may rival the surface biosphere in mass and volume. The organic remains of microbes in the deep hot biosphere represent the source of biological molecules in petroleum as a biological overprint onto an abiogenic organic mixture. The proposal contains an implicit concession that the biological molecules in petroleum cannot be generated by polymerization of methane. Echoing some of the previous arguments of the Russian-Ukrainian school, Gold presented several lines of evidence for the abiotic petroleum, including first, the presence of clearly abiotic hydrocarbons and other organic molecules in meteorites and other solar system bodies. Plausible synthetic pathways for mantle hydrocarbon production. Third, the association of hydrocarbon deposits with helium and other trace gases, presumably from mantle sources. Fourth, the existence of extensive deep microbial communities that impart an overprint of biomarkers onto the abiotic petroleum. Fifth, the tendency of hydrocarbon reservoirs to occur at many depths in a single locality, implying an underlying deep source. Sixth, the distribution of hydrocarbon deposits related to underlying mantle structures. Seventh, the distribution of metals and other trace elements of petroleum which correlate more strongly with chondrite compositions that presume crustal sources. And eight, the occurrence of hydrocarbons in non-sedimentary formations such as crystalline rocks. Clearly, looking at both the abiotic and biotic theories of the creation of oil, we can see which one is scientific and which one is not based on facts. If there are no further questions, I will retire and allow my partner Jacob Shaw to stand and represent the second point of error. We pray that you vote for the petitioner in this case. And we're done. Huh?
Hey, Joaquin, a good explanation.
Thank you. Gracias.
Ah, felicitaciones.
Sí.
¿No te da sed después de leer tanto?
¿Mande?
Don't you get thirsty after speaking?
Sí. Mucho.
Uh, what you have read is a conclusion on a report, or it is a research that you have made by yourself?
Uh, it's a mixture of both. It's a research and a question, basically just an argument put together.
How do you understand that subject about the fossil sources
Uh,
fuel?
I just understand it because through studying it and reading it.
What? How long do you consider that mankind will depend on fossil fuels?
What is that?
What?
How long do you consider mankind will depend on fossil sources of fuel?
Or when do you think fossils appeared?
Oh, a really long time ago.
Yeah, see, I don't think that we really have, the situation is, I don't think we really have the truth on how long fossils have been here, let alone the idea that fossils caused oil, because it would take millions and millions and millions of years and trillions and trillions and trillions of dinosaurs, which would have been way overpopulated.
There are no